Hi guys, Miss O'Connor here. So I have some updates about the new format for the AP exam. So I'm just going to take a bit of time today talking about that, and we'll take a look at some example problems. So as outlined in the first video about AP exam updates, which was posted about 2 weeks ago, this information was already on those slides, but I'm going to share this document with you just so you know exactly which units will be on the AP exam. Unfortunately, again, they took off 2 units that we already spent a considerable amount of time learning. So unfortunately, those units will not be on the AP exam. But that's okay. So we have 2 more units to cover. We have energy, which we are in the middle of talking about right now. And then we have torque and rotational motion. So unit 1 is kinematics. So mostly one-dimensional is what they focus on, but there is some two-dimensional information in there as well. Unit 2 is dynamics, so Newton's first law, second law, third law, okay, and applications of those laws. Unit 3 is circular motion, so uniform circular motion, applications of uniform circular motion, gravitation, so that's Newton's law of universal gravitation, that's in there as well. So we did talk a bit about that as well. In addition to what's a vector, what are forces, etc. Unit 4 is energy, so energy in closed and open systems. Right now we've talked about elastic potential, gravitational potential, and kinetic energy. We just need to apply that to conservation of energy and work. Okay, our previous unit was momentum, so momentum and impulse in open and closed systems. Basically, the AP exam will focus on one-dimensional momentum. It's very rare that they mention two-dimensional because it clarifies linear momentum. So we're looking at conservation of momentum in one dimension. Simple harmonic motion, which we spent a good amount of time talking about. So period, amplitude, frequency of objects that are vibrating in simple harmonic motion. So that's like our pendulums, our spring mass systems, etc. Torque and rotational motion, which we will get to starting probably a week, midway through the week when we return from spring break. Okay, exam dates. So the first exam date is May 14th. The test is at 4 p.m. and it'll be 45 minutes. Okay, so May 14th at 4 p.m. The reason why it's at 4 p.m. is because you would take it on the computer. Every person taking the AP1 exam internationally would take it at the same exact time, so that there's no cheating. So yes, you have to start the test at 4 p.m. on May 14th. There is a makeup date, so you have the option of taking it May 14th at 4 p.m. or June 2nd at 2 p.m. Okay, so if you wait till June, you have more time to study. If you take it in May, you'll have less time to review, but it might be fresher in your mind. Okay, so we'll talk about pros and cons of which date, and then we need to make a decision. So exam timing. You will have 2 questions that you will answer online. So you will have 25 minutes to read and respond to question 1, 5 minutes to upload your response, and then after you upload your response to question 1, which you cannot go back to, so you must complete question 1 before starting question 2, and you must upload question 1 before you start question 2. So after uploading your response to question 1, you will have 15 minutes to respond to question 2 and 5 minutes to upload your response to question 2. Okay, once you have submitted your response to question 1, you cannot go back to it. In order to start question 2, you must submit your response to question 1. So it's a little bit different than how our typical open-ended section of the AP exam is. You can usually move back and forth between questions, and you can't do that on this test. You have to complete a question, submit it to start the next question. There are only 2 questions. The first question is worth 60% of the exam. The second question is worth 40% of the exam. Okay. So the first question is going to be qualitative/quantitative translation. So what that means is that you will have to switch back and forth between quantitative justifications. So sentence form, you must explain in sentences using the concepts to justify whether an answer is correct or incorrect. On our vector test, your open-ended question was a qualitative-quantitative translation question. So I'm not sure if you remember, but we were given 3 different student responses about the type of triangle that could exist or type of system of vectors that could exist based on a statement that A could be larger than B, could be larger than C. Okay, and you had to pick which sheet was correct and then justify using your understanding of vectors. Okay, so that was an example of a quantitative-qualitative translation problem, and we will get to another example of that in a few minutes. So basically, it assesses your ability to translate between concepts and math to justify and reason whether an answer is factual or possible. Okay, so we've had 2 of those on our AP exam practice tests in the past. Okay, so there are 5 different types of questions for free response, and we've practiced a good amount of all types, except for this question, unfortunately. So it's paragraph, argument, short answer. So we have not seen an exact question like this before. Parts E, sometimes it asks you to justify or explain if something were to change, how would the answer to the previous part change? Okay, but this type of problem is an actual paragraph response. So we're going to have to practice these a little bit more. We'll spend some time doing that. So basically you create a paragraph length response which consists of an argument, and you must use concepts of physics to explain in addition to the information that's already presented to you in the problem. You must use the concepts of physics to explain in a rational, logical way the answer to that question. Okay, so that is a paragraph response. And it will usually tell you in the problem, do not use equations to justify your response. So the reason why they have moved completely away from or further away from the use of equations is because it would be very difficult to, in terms of test security, make sure that students are not cheating. Okay, if you have 15 minutes to write an entire paragraph explaining how the response is correct or incorrect using concepts of physics, it's really hard to cheat that way. You don't really have enough time to cheat, and you also would be very difficult for you to do that without them being able to tell. Okay, so they run it through software that basically tells them if you have too many phrases that are similar to another person, and you would obviously be penalized for that. Yes, so that is why these types of questions are being favored. It would be very difficult to cheat if you were asked these 2 types of questions in a 45-minute time frame. Okay, so good news, the test isn't 3 hours, it's 45 minutes. Bad news is that you have less of an opportunity to show how much you know. So we're going to work a little bit on these types of questions together. Before we talk about those types of questions a little bit more in depth, in the actual document that you see on screen, which I shared with you, there is a review, set of review videos linked in the College Board YouTube channel. They're really good review sessions. Please make sure that you only watch the review sessions for the units that will be on the test. because they are posting units that will not be on the test to teach kids who haven't had an opportunity to learn that information, to teach them that information, but it's not on the AP exam. Okay, so for right now, I would focus on units 1 through 7. There are review videos posted here, and I suggest that you take a look at those over spring break. I will be posting more review resources as we move forward. Okay, so let's take a look at some example questions. So the QT question, which is qualitative translation question. We have looked at a few of those before, but I'm going to have you guys actually try this one today. So this one is based on friction. This is actually a lab that we have done before. So these types of questions are worth 12 points. You get the 25 minutes to take it. It's worth 60% of the test, and you have 5 minutes to upload. Okay, so I'm going to read the question to you. So this is from the 2017 exam. A student wants to determine the coefficient of static friction between a long, flat wood board and a small wood block. Okay, so determining coefficient of friction. We did this using shoes. Okay, but here we have a long, flat wooden board and a small block. So a block on top of a board. Describe an experiment for determining the coefficient of static friction between the wood board and the wood block. Assume equipment usually found in a school physics laboratory is available. Okay, so think of the view of the shoe lab. All of the resources you used in that lab, you're replacing a shoe with a small block. So for part A, segment I, you're drawing a diagram of the experimental setup. So where would you put the block compared to the wooden ramp or surface? In your diagram, indicate each quantity that will be measured and draw or state what equipment will be used to measure each quantity. Okay, so this one is an experimental design version of the QQT. So instead of translating from an answer choice to a justification, you're translating or determining a lab setup. Okay, so you're designing an experiment. Okay, so part A, I describe the overall procedure to be used, including any steps necessary to reduce experimental uncertainty. Give enough details so that another student can replicate the experiment. So basically, you're drawing a diagram, labeling the parts, creating a procedure. Step 1, gather these materials. Step 2, measure blank. Okay, so you have to create a procedure that another student could follow. So diagram, label the quantities in the diagram, come up with a procedure on how you'd find mu of the surface. Okay, B, derive an equation for the coefficient of static friction in terms of quantities measured in the procedure from part A. Okay, so you want to come up with an equation in which mu is solved for. Okay, so unfortunately you can't look at your mu of the shoe lab when you're taking the exam, but we came up with a quantity to easily measure mu. Okay, so this is definitely doable. You've done it before. It's just completing it in a time period. A physics class consisting of 6 lab groups wants to test the hypothesis that the coefficient of friction between the board and the block equals the coefficient of kinetic friction between the board and the block. Each group determines the coefficient of kinetic and static friction between the board and the block. The group's results are shown below, with the class averages indicated in the bottom row. Okay, so pooling data, coefficient of kinetic and coefficient of static friction, there's an average there. Based on these data, what conclusion should the student make about the hypothesis that the coefficient of static friction and kinetic friction are equal? Okay, so you should already have an understanding of mu sub k compared to mu sub s. So static coefficient of friction versus kinetic coefficient of friction, you should already have some idea in your head about which one is larger, whether they're equal to each other, etc. Okay, and then looking at that data, you're going to choose one response. They are equal, they are not equal, briefly justify your reasoning. Okay, and for this one, for this type of question, you will receive points if your justification is scientifically accurate and your answer choice here is not the one that's in the answer key. You can still gain points for your justification even if you choose the wrong justification. So if you choose the wrong answer choice but your justification is accurate in terms of physics, you will still receive points. Okay, so please make sure that you justify and you do not just choose an answer. Okay, part D, a metal disc is glued to the top of the wooden block. The mass of the block disc system is twice the mass of the original block. Okay, so it's asking you how mass affects coefficient of friction. Does the coefficient of static friction between the bottom of the block and the board increase, decrease, or remain the same when the disc is added to the block? Increase, decrease, remain the same? Briefly state your reasoning. Okay, so you should immediately already know the answer to that question as well. Does mass affect mu? Does it cause an increase in mass? Would that cause an increase, decrease, or no change? Explain. Okay, so that comes from what the definition of mu is. So what I want you guys to do is to try this problem. Okay, I would spend 25 minutes on it. Complete as much of the problem as you can in 25 minutes. You can either print out this page and do it on the page or do it on lined paper. On the AP exam, they will give you more room than this to write, but when they publish the documents, they squeeze all the text together. Okay, so you will have more room than this to write on the actual AP exam. So I want you to try this out. I've posted the scoring guide. I want you to give yourself a score for this one question. Okay, on Wednesday, you will have a video to watch regarding the answer to this question. Okay, and reasonable justifications or exceptions to that solution key. Okay, so this problem is technically due on Wednesday, so you must have it done before class on Wednesday. Okay, but today is your lab period, so you have plenty of time. I suggest that you get it done today. Okay, and these questions are posted in Classroom as well. Okay, so this document is also posted in Classroom. You can find it in the assignment link. The second type of question, which is worth 7 points, it's worth 40% of your test. You will get 15 minutes to take or answer the question on the AP exam, 15. Okay, so this is a paragraph response. The physics class is asked to design a low-friction slide that will launch a block horizontally from the top of the lab table. Teams 1 and 2 assemble the slide shown above and use identical blocks 1 and 2 respectively. Both slides start at the same height D above the tabletop. However, Team 2's table is lower than Team 1's table. To compensate for the lower table, Team 2 constructs the right end of the slide to rise above the tabletop so that the block leaves the slide horizontally at the same height H above the floor, as does Team's 1 block. See figure above. So table 2 is shorter. They add this little ramp to the end of their incline. Okay, what you're asked to do, if both blocks are released from rest at the top of their respective slides, do block 1 and block 2 land the same distance from their respective tables? Yes, no, justify your answer. So in paragraph form, you're picking one and you're justifying your answer. Again, if you pick the wrong answer and your justification is physically accurate, you will still get points. Okay, you only get 1 point for choosing yes or no correctly, all of the points for this segment really come from your justification. So it's important to spend time in your justification. So you're going to arrive at the correct answer, yes or no. Will they land the same distance from the table? Think about your marble launch lab. Okay. You're going to justify your answer. In part B, okay, another experiment seems wanting to use the tables and low friction slides with the same height. However, the two slides have different shapes as shown. They're both released from top of their respective slides at the same time. Which block, if either, lands further from its respective table? Okay. Briefly explain your reasoning. You cannot use equations as a reasoning. You must use concepts and words. Okay, so it literally says without manipulating equations. So if you're not supposed to use equations, it will tell you explicitly not to use equations. Second portion, which block, if either, hits the floor first? Okay, so part B, sub I, there's some thought that should go into that. So for the second part, though, you should immediately be thinking of the answer. Block 1, block 2, they hit the same time. Briefly explain the reasoning without manipulating equations. So you must use concepts to explain which one of those is correct. Okay, in paragraph form. So 3 sentences, right? Alright, so you're going to give this one a try as well. Okay, if you have time here, but you're going to focus on this question here. So focus on question 2 today, make sure that you finish it, and then you self-assess. Okay, we'll be checking that on Wednesday. You can also take a look at this equation, or this question. Okay, answer key to that will be posted on Thursday. Alright, so give these a try. Let me know if you have any questions. And I will talk to you guys tomorrow.